Alright, we just got done looking at the triangles and how they apply to each of these special angles on our unit circle. We've also talked about the quadrantal angles and the x and y values for those. Now, why are these x and y values so important? The reason they're so important on the unit circle is since the hypotenuse is 1, instead of having to have opposite divided by hypotenuse, we can just use the opposite side for sine. And instead of having to have adjacent side divided by hypotenuse, we can just use the opposite, just the x value for the adjacent side. So y is the opposite side, x is the adjacent side, hypotenuse is 1, so even though this would be opposite over hypotenuse and adjacent over hypotenuse, it would just be divided by 1 and that value doesn't change. Okay, let's go ahead and use this idea to find the sine and cosine of the following angles. I always like to sketch a picture of my angle in standard position. It doesn't have to be pretty. So 270 would be here. That helps me remember where the point is that it crosses the unit circle. So that's going to cross at 0, -1, correct? That means that the sine of 270 is -1, and the cosine of 270 is 0. Now you can check these with your calculator. You are expected, though, to know some of this stuff without a calculator. There will be portions of your tests that are to be done without a calculator and portions that you can use a calculator for. So basically, learning what's on that circle chart and the x and y values for the specific angles that are on the chart is kind of like learning your times tables in 3rd grade. It's going to be so much easier if you can just automatically know what they are or be able to figure them out quickly. Here's a sketch of -pi. So obviously that's 180. So that would be at a point of -1, 0. And so our sine of -pi would be 0. And our cosine of -pi would be -1. Okay, 45 degrees would just be this angle here. The point we talked about on our previous videos is from a hypotenuse of 1, our x and y values will be square root of 2 over 2. So the sine of 45, as we just talked about, is square root of 2 over 2. And the cosine of 45 is the same because in a 45, 45, 90 triangle, the opposite and adjacent legs are the same length. Okay, then we have pi 6. Just because it has a 6 in it doesn't mean it's 60 degrees. In fact, it's the opposite. It is 30 degrees, right? So while both 30 and 60 degrees come from the same triangle, the opposite and adjacent sides are switched. So if you're doing the sine of pi 6, because it's a 30-degree angle, the y value is shorter, so that would be 1/2. And the cosine of pi 6 would be the x value, which is longer, and that is square root of 3 over 2. And the last one, cosine of, our 60-degree angle would be more this direction, giving us a longer y value and a shorter x value. So the sine of 60 would be the longer, the y value, the square root of 3 over 2. And the cosine of 60 will be the 1/2. Alright, so these three are all quadrant 1 angles. As long as you memorize these quadrant 1 angle values, you can find the sine and cosine, and therefore all of the other ratios. That's what we're going to talk about in section 1.4, by just using the first quadrant and then adapting to which quadrant it is to whether it'll be positive or negative. Before we get into that, though, let's talk about reference. reference angles. Okay, so a reference angle is the acute angle, we're going to call it alpha, between the terminal side of theta and the x-axis. So you're going to take your angle and draw it in standard position. We're going to call that theta. So like in this picture, theta is just first quadrant. This one, theta, you can see is marked right here as second quadrant, etc. Alpha is going to be the reference angle, which means it's going to be an angle between 0 and 90, because it's the angle that would be in the triangle itself that the SOHCAHTOA sine, cosine, tangent stuff is based on. So first we need to make sure we know how to find the reference angle, and it's different for each quadrant. In quadrant 1, the reference angle is literally the same as the angle itself. They're just the same. By the way, the triangle that we deal with is built by drawing a vertical line to the x-axis. It doesn't matter if it's the positive part of the x-axis or the negative part of the x-axis. It's just always to the x-axis. So here you can see, draw a line to the x-axis. There's our triangle. There's the angle within the triangle. That red part there is what we call the reference angle, alpha. So theta is this bigger angle, and alpha is this smaller one, and together those two angles add up to 180. So to find alpha in quadrant 2, we take 180 and we subtract theta, because theta is going to be smaller than 180 but bigger than 90. In quadrant 3, our angle is now bigger than 180, and so instead of it being the angle we add to the other angle to get 180, it's going to be the opposite of that. It's going to be taking the angle that's bigger than 180 and subtracting 180 from it. And that will give us the space between this angle theta and the 180, right? The space in here, that's what we want. That's our reference angle. And then, of course, you can adapt these to be in radians if you need them to be, like pi. Correct? And then this one is by going vertical line up to 360. And so this is going to be an angle that's between 270 and 360. So to find that reference angle, we do 360, subtract our angle, and that will give us our smaller acute angle, reference angle, in quadrant 4. All right, let's look at each of the quadrants and what the sines would be. So we just talked about how sine is the y value and cosine is the x value. Well, in quadrant 1, we have x value, y value, both positive, right? So all of them will be positive. When I say all, that means like tangent and cotangent and secant and cosecant, as well as sine and cosine. All of them will be positive. In quadrant 2, our x value is negative and our y value is positive. That's why sine will be positive and cosine will be negative. And as a result, this is more what we're going to be learning in the next unit, but tangent will also be negative because sine is y and cosine is x, but y is really just the opposite side and cosine is the adjacent side. So tangent will be the opposite divided by the adjacent. So if you have a positive divided by a negative, you're going to get a negative. And then their reciprocals are going to have the same exact sign that they do. So in this particular quadrant, sine and cosecant, its reciprocal, are going to be the only ones that are positive, and everything else will be negative. In quadrant 3, we have negative x value, negative y value, which means both x and y are negative, so both sine and cosine are negative. But then, since both of our opposite and adjacent sides are negative, if we divide those to get our tangent, a negative divided by a negative is going to be a positive tangent value. And then in quadrant 4, we have a positive x value and a negative y value, making our sine or opposite side negative, cosine, adjacent side is positive, so then opposite divided by adjacent tangent will be negative in that quadrant as well. Okay, let's go through some more examples. Find the quadrant, the reference angle, and the sine and cosine of the following angles. So I'm just going to sketch a little picture for each one. Should be starting to get the hang of these. 225 is here, so that's in quadrant 3. You can use Roman numerals if you want, it doesn't really matter. And then we're going to take 225. It's in quadrant 3, so we're going to subtract 180 because 225 is bigger than 180. That gives us a 45-degree reference angle. So the ratios are going to be the same as they are for the 45-degree angles that we talked about here and on the page with the triangles, right? So we've got 45-degree reference angle. However, in quadrant 3, sine and cosine are both negative. So the sine of 225 is going to be negative square root of 2 over 2, and the cosine of 225 is also going to be negative square root of 2 over 2. Okay, next question, 11 pi over 6, it's like all the way around to here. Technically, to find that reference angle, we would take 2 pi, and we would subtract 11 pi over 6. Now, hopefully you're going to see the beauty in radians, because if we do that, we need a common denominator, 12 pi over 12, over 6 actually, sorry, subtract 11 pi over 6 is just pi over 6. The reference angle is literally always going to be the same fraction number on the denominator, and you just eliminate the number in the numerator. So ignore the 11, pi 6. That's your reference angle, 30 degrees. Okay, so quadrant 4, though, means that our sine will be negative, our cosine will be positive. So the sine of pi 6 is normally 1/2. So the sine of negative 11 pi 6 will be, wait, I did this wrong. Gosh, you're probably sitting there going, no, she's doing this wrong. Okay. Now I'm really going crazy because I'm the one who put the negative in there. It's not negative. It's positive. 11 pi 6. It's a negative pi 6. I should go home. Okay, sine of 11 pi 6 then is the same as the sine of pi 6, except it's negative, so negative 1/2. And then the cosine of 11 pi 6 will be positive square root of 3 over 2, the same as it is in quadrant 1. All right, using our trick again, what's our reference angle? It's simply pi 4ths. However, we still need to know what quadrant it's in. So negative 5 pi 4ths would go around past pi plus some. So about right there. That's in the negative direction. So that would be quadrant 2. And our reference angle, of course, is pi 4ths because that part's easy. And then in quadrant 2, sine is positive, cosine is negative. So the sine of negative 5 pi 4ths will be positive square root of 2 over 2. And the cosine will be negative. Has nothing to do with the fact that the angle itself is negative. Has everything to do with what quadrant it lands in and what the x and y values are in that quadrant. Okay, here's our last one. 7 pi thirds. Hopefully you recognize that 6 pi thirds would be 2 pi, right? So that means that this is going to go all the way around plus a little bit. And so our reference angle, oh, this should be more like up here, huh? So our reference angle is going to simply be pi thirds, and that's in quadrant 1. So our sine will just be square root of 3 over 2, and the cosine will be 1/2, just like it is for pi thirds, because that's the same coterminal angle.